Would you like to talk amongst yourselves? I'm gonna take a roll while you do it. Here. How many reals do I got on the right hand side? I got 0 of them, right? So I have x plus y plus, minus 4 is 0. And then what's my imaginary equivalent to? So I got 2x equals 5 minus y. What does this actually end up having us do? Systems of equations solving simultaneously. I knew y'all would love that. So, or not, right? So x plus y is 4, and I could do 2x plus y is 5. I prefer method of elimination. Y'all prefer whatever. Some of you even like to graph. I don't. No, I'm just kidding. Nobody really likes to graph. So if I subtract that all down, I got x. The y's go away. I got 1. Did you get x equals 1? Nice. So I'm going to plug in 1 plus y is 4. Y is 3. Are we cool? Yes? No? Maybe? Yes? Yes? No? Feeling it? Feeling good? A good question for you from yesterday. Okay, ready? 5 plus I times the square root of 3 is a root of a quadratic equation. Tell me the quadratic equation.
Plus or minus b equals the square root of b squared minus 4ac all over 2a.
That is to solve a quadratic equation. You absolutely got that on your brain. That's awesome.
Oh.
Yes?
You multiply it by the conjugate thing.
You multiply by the conjugate. Because when you multiply this by the conjugate, wait a minute, why did we decide to pick a conjugate?
Because it's
Good question.
If
If that is a root, then its conjugate has to also be a root. Because remember, there is no such thing as a singleton complex number as a root for any quadratic. So if 2 minus 3i is a root, then what would have to be also a root? 2 plus 3i. So yes, you are 100% right. You knew.
It says is a root of a quadratic equation.
So you're going to actually take its complex conjugate and you're going to FOIL that puppy out. Wait a minute, don't FOIL it out because you're going to get a real number. Let's go backwards for a minute. If I know like x equals 3 is a root of something, in actuality, what is the actual factor of it? X minus 3. Yeah, so this would be x minus 3, right? So we got a little issue here where this is just going to show that they're complex conjugates. What do I got to do here? You're correct in using that other one. 100% correct. Let's go this route. If I told you x minus 3, let's review the past. If I told you x minus 3 and, x equals 3 and x equals 2 are roots of a function, how do you go about finding the original function?
x minus 3
X minus 3.
times x plus 2.
Yeah, and then we FOIL it out, yeah?
Yeah.
Right, that's true, 100%. So if I tell you this guy is a root of the function, you already know what also has to be a root of the function.
5 minus I squared.
Perfect. So yes, both of them, now let's go back over here. You were very comfortable with moving it over and then foiling it. That's kind of second nature to us. So what are we going to do over here? Subtract them all over. So you're going to have z minus 5 minus I squared of 3 is one root. This is exciting. What is the other root going to be?
Z minus 5 plus I squared.
And over here, how did we find the original quadratic? We did what to this? We multiplied it foiling because they're both binomials. So what are we gonna do over here? We're gonna multiply, however, FOIL's not our friend here. What are we gonna do? Z times everything over here, right? And then -5 times everything over here, and then -I squared to 3 times everything over here. Clean that puppy up, you'll have your quadratic. Let's do it. Or not. So Z times Z is Z squared. Do I need to do it out loud, or are you guys cool? You do it, I do it, and then we'll check. See how good my math is? How'd it go? Lovely? No? Check my math, it's possible it went right.
No, it's just like, multiply the square root of 3 and the square root of 3 together to create the square root of 3.
Oh, beautiful.
Yeah.
I feel that pain.
For the next topic.
We don't feel? Are we good? Not bad, it's just old-fashioned algebra 2. Speak for yourself, right? Okay, so, let's do, are we good, or can I move on, or no? Yes. Okay, so I have z to the third minus 3z squared minus 3z minus 4 is 0. Step part I or A or I or whatever, I want you to show z equals 4 is a root of this function. Z equals 0. It's that easy. Yeah. Well, I don't know. Maybe it's not that easy because they're big numbers, but whatever, we got that. You guys all have those handy dandy calculators. I think so. Okay. So, back chapter 1, you were able to figure out whether something indeed was a root. Yay, we're doing it again. That's exciting. It's a good review for chapter 1. Then it says, the next part of this is, let's factorize completely. Do we know it's a root now? Sure we do. In essence, what really is a root? If z equals 4 is a root, then what is its factor? Z minus 4, yeah. So I know, because it turned out to be 0, I know z minus 4 is indeed a factor. So how do I go about factorizing completely? Well, let's talk for a minute. How many roots is this thing going to have? It's going to have 3. Currently it's got 1 real, so it potentially could have 3 reals, but we're in complex numbers, so it's not going to have 3 reals, it's just going to be real. All right, and so what is the other option? Complex, 2 complex numbers. So if I'm able to get one of them, I got the second one as well. What's the easiest way to factorize this? We can divide. We have 2 options. What are they? Long division or synthetic. Is this considered a linear factor? Sure. I think synthetic would really work for us. So I'm going to take the number 4 and I'm going to put it in the 1, the -3. Things to remember is that you can't miss an exponential power. Does that ring a bell? There's cube, squared, first, and we're good to go. Okay. Does anybody need like a recap on how to do that synthetic division, or are we good? All is well? So now the next question I have is, z minus 4 is a factor. What's this factor here?
Z squared plus Z plus 1.
Z squared plus Z plus 1. And I know z minus 4 is a factor. I could quickly look at it and know that it really doesn't factor. However, if I'm on an AIce exam at the end of the year and I'm trying to really think, does this thing factor? And what's like the quickest way for me to look at it and say, yes, it has a good factor reals, or we're going to be working with imaginaries. Do you guys remember from last year? Do you guys remember the discriminant b squared minus 4ac? Did you say it?
Yeah.
Beautiful. If you can do the discriminant really quickly in your head, like b squared is the number 1. Minus 4 times a times c. I know 1 minus 4 is going to be a negative number, so I know my next 2 answers are going to be imaginary. It's not necessary, but sometimes it's nice to figure out which way I'm going instead of racking my brain on how to factor something. So how do I, if I know in advance it's going to be imaginary, what shall I do? What's the easiest way to factor this? Quadratic formula. Yeah, your quadratic formula. Or your Casio class whiz calculators, for what it's worth. I have a little jealousy there. So negative b plus or minus the square, and so does Sydney, because she never got one for her love day, but that's okay. Well, you're not speaking now. So sorry. It's all about the calculator. Having said that, I don't have one either, so you could be like me. Like you. Okay, so negative b plus or minus the square root of b squared minus 4ac all over 2a. Look how easy that was in your brain. You don't need who needs it? Nobody needs a Casio in this life.
I do.
So, I know, you know what, if I was your age, I probably would want one too. I'm trying to keep my brain a little bit young. So 1 minus 4 is negative 3. Oh, did I already do the I? Jump the gun there. Negative 1 plus or minus the square root of 3 and I. I do caution you, let's talk a little bit, that oftentimes it's a little nicer to put the I in the front, although very awkward feeling. But because sometimes your little house that your square root goes, sometimes just goes a little too far and that I goes where it shouldn't go. It should be on the outside, not on the inside, and the examiners will mark it wrong. So just be very careful and cautious. If you know that, if it's real obvious, like what I've got going on here, that there's outside, or just stick it out front and then you for sure can show them you know better.
It has to get parentheses.
How was that?
Parentheses in the back.
Parentheses in the,
You could do that.
you could. I like that idea, as long as the little house doesn't go over it. So now, how do I write this as a set of linear factors? I challenge you to do that for me. Yay, have fun with that. If I'm looking for the actual roots, we've done it, but I'm looking for you to factorize completely, which means I'm looking for the answer z minus 4 times.
Do you have to use z, or?
They give it to z. They love z's. They're in love with z's. So I'm not going to tell you that. Yeah. Can somebody tell me what the first one is?
Negative 1/2 plus I squared root of 2.
That is the root. I want the linear factor.
Your root. So that would be z. Oh my god.
Z plus 1/2 minus
The square root of 3.
square root of 3i over 2. Indeed. Now, what's the next one? Z, also plus 1/2, yeah. Plus the square root of 3 over 2i. So if the question asks find the linear factors, this is your answer they're looking for. If they say find the roots, you've got the answers over there. The first root would be z equals 4, and the other would be these two guys right here. So there is a distinction between those two types of questions. Yes, are we cool? Okay. All right, we give you another one to try without me.